Good morning. I am Dr. Kavitha Rani, Assistant Professor of Chemistry, SFR College for Women, Shivakashi. Today I am going to take the class on nucleophilic substitution reaction. Okay, the learning objectives of this topic: first, introducing the nucleophilic substitution reaction, then classification of nucleophilic substitution reaction, and one of that is SN2 reaction, and write the mechanism of SN2 reaction and stereochemistry of SN2 reaction mechanism, and then what are the factors influencing the SN2 reaction. First, introducing the nucleophile. What is nucleophile? Nucleophile is a electron rich species. It is a chemical species having electron negative or lone pair of electrons are having. Such species are electron rich species. These are called nucleophiles. Nucleophiles are two types: negatively charged, for example hydroxides, halogens, chlorine, bromine, iodine, fluorine, these compounds have a negative charge. Because of accepting electrons from other atom or group, it has become a negatively charged. So it is a negatively charged nucleophile. And other type is neutral nucleophiles. Neutral nucleophiles which have lone pair of electrons. The oxygen atom having two lone pair of electrons and nitrogen atom having one lone pair of electron. The lone pair of electrons carrying groups have neutral nucleophiles. For example, water molecule is a neutral nucleophile. Ammonia is a neutral nucleophile. Then what is nucleophilicity? The ability of donating electrons to the electron deficient species is called nucleophilicity. It is a determining based on the rate. It is a kinetic term. Nucleophilicity is defined as the ability of a nucleophile to donate electrons to the electron deficient species is called nucleophilicity. And these are affecting the factors are charge, steric hindrance, and solvent effects are affecting the nucleophilicity. The negatively charged atoms or groups or ions are more nucleophile than neutral nucleophiles. And the nucleophile have bulkier groups which the size is hindered by the approaching another target atom. So the steric hindrance reduce the nucleophilicity. And then affecting factor is solvent effect. Solvent effect is polar aprotic solvents and polar protic solvents. Polar protic solvents, that is the molecule, water molecules and alcohols are the polar protic solvents. These solvents have a ability to solvate with the solvent, and there is a possibility form the hydrogen bond with the solvents. So that reduce the nucleophilicity. Whereas polar aprotic solvents like acetone and dimethyl sulfoxide, there is no possibility for the formation of hydrogen bonds. So its nucleophilicity will increases. Then the reactions, the organic reactions are carried out by addition reactions, substitution reactions, elimination reactions, and rearrangement. Here we are taking the substitution reaction. Substitution reaction is nothing but it is this one of the atom or group is replaced by another atom or group is called a substitution reaction. Substitution reactions are carried out by either radical or nucleophile or electrophile. These are the factors. Substitution reactions are carried out by radicals, nucleophiles, and electrophiles. The nucleophile attack on a substrate carrying living group. The living group is displaced from the substrate and the nucleophile attached to the substrate, and there is a formation of a nucleophile and substrate bond. This new product is formed. This is a substitution reaction. The attacking of nucleophile on the substrate carrying living group, there is a new bond is formed, that is a covalent bond that is formed between nucleophile and the substrate carbon atom. That should be a saturated carbon. Such reactions are called nucleophilic substitution reaction. The representation of nucleophilic substitution reaction, that is nucleophile attacking on the substrate, that is an alkyl halide. Alkyl halide is a leaving group and alkyl group attached to nuclear halide, that is a substrate, and the halide is leave from the substrate and a new bond is formed between nucleophile and saturated carbon atom of the substrate alkyl group. Then it form a new compound that is called as nucleophilic substitution. It is represented here like that. Then the leaving group, a good leaving group are the substituents must be able to live and relatively stable, and weakly basic nucleophiles or ions are less leaving group. In alkyl halide, the leaving group is a halogen substituent. It leaves the halide ion. Because the halide ions are relatively stable and very weak, these are good leaving groups. Weak bases are good leaving group. Weak bases like the iodine is a weak base and is a good leaving group. Fluorine. Then what are the types of nucleophilic substitution reaction? SN1 reaction, SN2 reaction, SNI reaction, they are the main classifications of nucleophilic substitution reaction. SN1 reaction is a two-step mechanism. The formation of carbocation is the first step, and there is then nucleophile attack on the carbocation. So the rate is depends upon the concentration of the substrate only. So it is a unimolecular substitution reaction. Unimolecular substitution reaction is a two-step reaction. First, the carbocation intermediate is formed, then nucleophile attack on the carbocation to form the new product. So the rate is depends upon the concentration of substrate only. Whereas SN2 reaction is a one-step reaction. The nucleophile attack on the substrate and it simultaneously leave the leaving group. So it is a rate of the reaction depends upon the concentration of substrate as well as the concentration of nucleophile. This is a one-step reaction. Another one is SNI reaction. The nucleophilic substitution reaction is an intermolecular nucleophilic substitution reaction. The leaving group and nucleophile both part in a same molecule, that is SNI. This is an internal nucleophilic substitution reaction. Then we are coming to the SN2 reaction. We are deeply considering the nucleophilic SN2 reaction, nucleophilic substitution bimolecular reaction. The rate of the nucleophilic bimolecular reaction depends upon the concentration of substrate and concentration of the nucleophile. Substrate is the alkyl halide and concentration of the nucleophile is the hydroxyl group. Here the rate equation is concentration of alkyl halide and hydroxyl group. Alkyl halide, the order is first order, and hydroxyl group also first order, then the rate become second order reaction. The the rate constant is K is a constant value. This is representing the equation. Rate is directly proportional to the concentration of alkyl halide and concentration of hydroxyl group. Alkyl halide is a substrate and hydroxyl group is a nucleophile. Then the mechanism is take place representing like that, and incoming nucleophile attack on the substrate on the backside attack. So the reaction is called inversion of configuration. The nucleophile attack on the substrate via backside of the substrate carbon atom. So there is a transition state is formed, and then coming to the final product. The energy represented, free energy representation is showing like that. The mechanism is showing like that. So first point, we have to notice one point. In SN2 reaction, there is an inversion of configuration, that is the incoming nucleophile will attack on the substrate on the back side. That is called the inversion of configuration. Then the stereochemistry is representing that the nucleophile attack on the carbon from back side. The leaving group leaves from the simultaneously. Then there is a inversion of configuration. That inversion is called Waldel inversion. That is represented by the equation. That is the stereochemistry of the SN2 reaction. Walder inversion is possible in. Then what are the factors affecting the SN2 reactions are first nature of the substrate and power of the nucleophile and the ability of the nucleophile leaving from the substrate and nature of the solvent. These are the four factors affecting the state of the SN1 reaction. Nature of the substituent, power of the nucleophile or nucleophilicity character and ability of the leaving group from leave from the substrate and nature of solvent. We will discuss each one. First one, consider the nature of substrate. The SN2 reactions, there is a possibility for attacking the nucleophile on back side. So the methyl radical is more reactive than primary, secondary and tertiary. Why it is more reactive? The methyl radical react quickly with the SN2 reaction. We will discuss in detail. That is the spacing. That is methyl radical, there is a hindrance of backside attack is very less, whereas the primary alkyl halides there is a hindrance is comparably higher than methyl radical. So it is representing in the figure. And then secondary alkyl halides, that is slightly hindered by the bulkier group or substituent on the carbon atom attached to leaving group. There is a hindering the attack of nucleophile on the back side. So its rate is comparing to primary, secondary is less. Then in case of tertiary alkyl halides, there is a 3 alkyl substances are present in tertiary alkyl halides. The carbon atom attached to leaving group, there is a less possibility to attack on the back side. Nucleophile with attack on the back side of carbon atom having the leaving group. So in tertiary alkyl halides it is a very less. So the order of methyl primary secondary is in this order. Methyl is first, then primary, then secondary and tertiary. So rapid action is possible in methyl radicals, then primary, then secondary. Very less possibility in tertiary alkyl halides. Okay, then nucleophile effect of nucleophile on the SN2 reaction. Whereas in vinyl alkyl halides, there is a double bond is present in vinyl bromides. So there is a possibility for the backside attack of nucleophile is very less. And bromide benzene, bromobenzene, there is also pi bond are attached to the pi bond are delocalized. So there is a no possibility for the backside attack of the nucleophile on SN2 reaction. So vinyl bromide and bromobenzene is less reactive towards the SN2 reaction. Then considering the power of nucleophile. Nucleophile, very weak nucleophile, very weak bases. For example, comparing the nucleophilicity of neutral compounds and negative compounds. Negatively charged nucleophiles are more nucleophilic than neutral compounds. Then consider the nature of leaving group. But considering the alkyl halides, halogens are the leaving groups. The iodine has the, comparing the leaving group nature of iodine and fluorine, iodine is more good leaving group than fluorine. And negatively charged nucleophiles are more reactive than not. Next, consider the nature of solvents. There is a protic solvents and aprotic solvents and non-polar solvents. Protic solvents down the SN2 reactions, and aprotic non-polar solvents are non-polar solvents and the benzene. These are the hydrocarbons that the SN2 reactions relatively in non-polar solvents is very less. Protic These are the factors affecting SN2 reaction, effect of solvent, nature of leaving group, nature of substrate, and power of the nucleophile. These are the 4 factors affecting the rate of SN2 reaction. Thank you for watching this video.